Hello everybody, my name is Avery, and today we're going to be creating a cave-like map using Cellular Automation. For anyone that's not familiar with Cellular Automation, it's kind of similar to, I guess it's what's used for the Game of Life, and if you guys ever, I assume you guys have seen it before, this is kind of what the Game of Life looks like. But basically we're going to be creating a grid of either basically cells that are alive or dead, and those cells are going to represent alive or dead. It's going to represent in the cave if it's going to be the cave ground or a cave wall, or if the cave's hollow or whatever makes sense for you. As we get into it, you'll see and you'll understand it a little bit better. And for doing that, we're going to just output it just into the terminal. It's just going to be saved as a 2D array. Of course, this could be a 1D array. It doesn't matter. It could be a vector in case you want to be changing sizes and whatnot. We're just going to include... Oh, right. My bad. We're going to be doing this in C++, but this can be done in any set of languages. If you guys are interested, maybe I'll come out with some tutorials showing different languages. Along with this is going to be level generations using Cellular Automata, but I'm going to be having a few other tutorials coming out soon showing a few other types of level generations for our 2D world. So we'll just, right off the bat, we'll have this right here, this our main function, and return 0. So we want to define the size of the map, and we'll just define it as such. We'll do map width, and define it like this, and then map height. We'll make the height just a little bit smaller because I'm going to be displaying it just in the terminal, and because of the, a character is taller than it is wide, so it's going to be a little, I just want to be able to fit like correctly in the terminal, but this can be used for any size basically. And then we'll also have an object to define if it's dead or not. I mean, this could be a boolean. It doesn't really matter, at least for this case. If you guys wanted to take your code and then also like adjust things to have different types of tiles, then you probably just want integers, because then say you wanted to have like different, generate different biomes or generate something that spawns inside the cave, you want to have different integers to represent every single one of the tiles in your game. And also to represent like curves on a tile or something like that. Like, for example, in this game that I've been working on recently, it's using a similar formula. You can see all these ones here are the ceiling or a wall, but you're going to want to have different integers to represent the different corners. And we're not going to do this ourselves, but I'm going to quickly explain it once we get to the point and how to do the corner edges and these little walls right here. Also, if you guys are interested in this game, I've been working on it this month. I have a few devlogs for it, so go ahead and check those out as well. But yeah, it's as simple as that. I'll close out this terminal. So we're just going to be having it if it's dead or alive. That's just equivalent to having it as like a wall or not. And they don't make the map. Like I said, this is going to be a 2D array in this example, but it can be anything. The map, we'll have it at, that's going to be the height, and this one will be the width. And so you just wanted to have a 1D, you'll just do that, you'll just multiply it, and then it'll be the correct size. And also for traversing a 1D one, say you have like the Y and the X, that's the 2D one. Here, I'll try to make... Alright, I got my font size up a little bit bigger. Hopefully this looks a little better. But like I was saying, this is a 2D array, and if you were to do it on a 1D array, this would be equivalent to doing something like Y times the map height plus X. Those would be the exact same thing. And then, of course, if you want this one to be the width and that one to be the height, then you just flip them all. That'll be, the X, the height, the width, and then the Y. But yeah, you can have it however you want it to be. So now moving on from here, whenever we do, I guess to get started to generate the cave, we'll just make this function right here called gen cave, and that'll be the first thing that we do right here. And in here we're going to want to have just set the randomness to something, and we'll have a seed for that. We'll just do end seed. And so if you wanted to, every single time you ran it, like kind of like in Minecraft or I guess Terraria, you know, if you put in the same seed, it'll generate the exact same thing. So you can have it, you know, have someone give it a seed or something like that, or you can save the seed. But for this case, we're just using something from the clock, the time, to set the seed. And then we're setting right here. And now we're gonna want to loop through our array, our 2D array, and we'll loop through the height first, and then, or the Y, or the columns, and then we'll loop through the width. And so we'll just call this one height, and then it'll be the map height, and like that. And then we'll do the same, I'll tap it, for the width as well. Okay, so now that we're looping through everything, now we can actually set some basic stuff, but let's just set it to, that's going to be Y. Oh no, that's height. So now we just want to set randomly everything, and we could just have it back and forth as random, but to make it so there's a little bit higher chance of having a ground or whatnot, we'll have a higher probability for having a ground, and this is kind of just something you can test around. So we'll do random, and this is why we need that seed, and we'll do it out of 100, and then if it's greater than the alive probability, then we'll do map height width equals dead. So now this is something that you're going to be testing around, and we'll just do int alive probability, and we'll set that to 50. So this is kind of a number that you can kind of just play around with to make it so once it's actually generating everything, that it'll work and look nice the way that you want it to. So 50 is just half and half chance. So that's just what we're going to do from the beginning, and then we'll kind of adjust it. So if we were to actually look through all this, we can actually set up a function to display the cave, or display cave. And then here we'll print out the cave so we can see everything that's in the cave. We can just copy this right here. Then this one right here, we'll just use cout, and we map height, width, and then you want to print it down here for the new line. So then, you know, it has everything in the same line, and once you get to the next row, it prints on the next line. And we can build this real quick to test it, except for we want to display the cave right here first. Save, no, save. Okay, looks like we have a few errors. We can check these real quick. So on line 5, or line, was it 5? No, line 4. Okay, these aren't supposed to have these semicolons. I'm just gonna, okay, that's all it was. And as we can see, it's 100 by 60. Like I was saying, the height was gonna make it look a little bit taller, but it's 100 by 60, just some random things. And there's more of a, I guess it's a 50% probability of it being either one of them. If we were to adjust this, now we can see there's more ones before. There's more alive ones than there are dead ones. Let's just adjust that back to 50. So now that we have this, we're going to actually do the cellular automation, the cellular automata, where it takes the live ones and then calculates if they should be live. It takes the dead ones and calculates if they should be dead. And for that, we're going to be doing something where it finds out the neighbor amount. It sees how many things are around it. We'll just create a function. We'll call it near. And in this function, we'll be giving a coordinate, an x and a y, something that we need to check inside of the grid. And then we're going to check the ones that are just directly around it. And the check that runs around it, we'll just have a count. We'll set that to 0. And then every time there's one that's around it that's alive, we'll just add it to the count. And I'll just copy and paste this once again. But in here, we're actually not going to want to do the whole entire map. We just want to check the thing. So that we're just going to have the int of x and the int of y. So every time you want to check it, this is what's going to be given to it. It's going to say, look at this position and then tell me the total neighbors that it has, at least of a distance of 1. And we'll do that. We'll just do y is height, and then for this one we'll do 3, and this one will be 3 as well. So 3 is basically just going to make it so, I guess, if I were to pull up an example, so we have this grid. This doesn't look too good, but now it's better looking. Yeah. So say we have a grid like this. So this is the grid I guess we're looking at, and then you don't imagine that the grid's much bigger. It's all this. But say this is the coordinate that we're given. We want to check all these coordinates and check if they're alive or dead. And we also want to check if this coordinate's alive or dead as well. But to do that, we'll just want to move it up, and we want to search every single direction from it. So by 3, it's just the size of every direction possible is 3. So in case you had a program where you wanted to check the next row, you can just do that by having the size of the distance you want to travel, which is 1, 2, and multiply that by 2 because you want to get both sides, and then add 1. I guess that makes sense, like say the distance times 2 plus 1. But in our example, the distance is going to be 1, which is 2, and that's just going to be 3. Hopefully that makes sense. My drawing's really not that great. But yeah, so this is going to check everything around it. Except for we don't actually want to check, we only want to check the edges. So we're not going to want to check this middle one. And to check the edges, I guess what we're going to do is just, in this case, because we're only checking the very closest edges, we can just easily check, make sure we're not looking at x or y. But in case we wanted to have a further distance, you just want to check to make sure that the h was equal to the y minus the distance, and the x was equal, well, the width was equal to the x minus the distance. But in this case, we're not using distance, so we can just make sure that it's not, not w doesn't equal x and height doesn't equal y. It's basically just as simple as that. And yeah, so if it's that, we'll just do count plus equals map of width, amount of width times height. Oh, that's my bad. So now it's just going to take all the edges and then just add it to the count. And now we're going to want to return the count as such. A good way of observing this, if we were to, I guess, where's the drawing down here? We can copy this drawing right here. And like I said, we can draw this, and then right here, else. And here is draw period. And this next line, draw the next line. So now we can just use that for a little bit of debugging, for seeing what it looks like. Hopefully this is easy to follow along, but I'm gonna display some stuff so you guys can understand a little bit better. So let's just do a sum of a random number. Let's do 20, 20. So now right here, and let's not display the cave. Oh no, it's called near, wasn't it? Not sum. Make sure it's actually looping everything correctly. Okay, so this actually is going to be 1 equal to y because it has an offset, so that one's going to be equal to x as well. There you go. So now we're trying to check the edges, but to check the edges, we're supposed to look at everything except for the middle one. W equals x height. Okay. Let's see what we're doing wrong. So we want it to be able to print out everything except for this middle one should be period. And oh wait, this is gonna be not equals. Let's see. Okay, that's still not correct. This is the middle one, supposed to be the period one, as I mentioned. So let's look at this. And okay, so these need to be offset by 1 because we're checking at the corner of it first. Okay, I think we're getting there. Let's change that to a 2, since we already have the. Okay. Alright, so we have y minus equals 1. That's too big. Okay, so we want to be able to look at both of these together, and call it like that. Okay, there we go. So let me explain that real quick. Sorry for the misunderstanding. So like in the image, this is where we're starting off, but we're looping through it like this, and then by rows. So we want to start up here. So I'll just do -1 and -1 on both the x and y coordinates. So that's the reason I adjusted this one right here to 2, because it's -1. And then also it's adding the y, because it needs to have an offset, because it's at the y. And then down here, we just want to make sure that it's not set to equal both of those. And if we were to look at this, it says there's 5 neighbors. There's 1, 2, 3, 4, 5. And we just run it again. Now there's 3, then 3, and then 6. So as you can see, it's working. So now that we know the count of the neighbors, we're going to be able to use the actual cellular automation to figure out if something should remain dead or alive. And we'll just do that right there. Let me just copy this again. I know we're using a lot of for loops. It's easier just to copy and paste it every time. So down here, we'll do if map each. So this is something that you kind of can just play around with the numbers. Like I said, it's the same thing with this alive probability. It's just something that we're going to have to test around to make it so it works as good as you want it to. But now we're going to say if the object is dead, but it has 6 or more neighbors that are alive, then the object is going to be alive. And now we're going to do something also saying maybe it should be dead. So if the object is alive, but most of its neighbors are dead, and we'll do a count of 3. If it only has 3 or more neighbors that are alive, which means all the other ones are dead, then it too should be dead. Sorry, I'm kind of stumbling around as I'm typing. But it's basically it's that simple. Now we can display that cave. Let's compile that, make sure it works. Okay, the count doesn't exist. Let's do int count equals near and width height. Okay, and then just printing out all that. Okay, so in the near, like I was saying, this is debugging stuff, so we can comment this stuff out. Now there's, let's change that to 1. Okay. So I just changed these ones right here to 1 because we just want to make sure that it's not going outside of its position, basically, or else it's causing the segmentation fault. Which just means that, you know, it's trying to look at something in memory that doesn't exist or anything else like that. And, you know, if it's at 0 and then I tell it near, and then near automatically checks -1, as we know, which is -1 in an array, and that's not possible. So just for this calculation, we're not going to be looking at the edges. But another way to fix that also is up here. Whenever you're checking them, you just can look at them manually. If it's x equals 0, y equals 0, or x equals the max, the map width or mapped height, and that's just something you can easily check. But for this case, that's just how we're going to do it, because it's just easier that way. But as we can see, we ran it, and I guess everything looks a little bit, it's not really displaying it's just not really that nice looking to look at it. So I guess what we can do is right here in our drawing, we'll just have it if this one is true, and what's true is going to be alive, then else, and then draws a period. This one is a pound. Okay. And as we can see, it's drawn a little better. Maybe flip these, and he even draws that a little bit nicer as well. But so that's one thing that we're gonna slowly adjust over time, because we're gonna do several different generations. This is only loop through it once, but let's try to loop through it multiple times. And this, like I said, is going to be, like I said with the other things, is going to be a number that you can kind of adjust to see if you like it or not. So let's call this generation, set that at 0, and then generations. So now we're going to set this up here to int generations, and we'll set that to 10. So now it's going to do that at least 10 times. And so that's the 10th time. So instead of changing the generations, let's adjust this by a little bit. We'll change that to 60. And as you can see right here, it looks way nicer. I found that at least with these numbers, I think 58 looks pretty nice. Simple as that. Here is everything. Basically, this is generating it. We can have it print out the display cave every single time. Let's do that down. We're actually, is that going to be right here, display cave? And we'll just make a new line so there's breaks in between them. And we'll go to the first generation. And the first generation, there's a, I guess actually we're not displaying the first generation, are we? And this is after it's already been modified. Well, it is the first generation, but we're not displaying the original generation. So now scrolling up here, this is the original generation, where it's all random. And this is using a seed, and it's using that alive probability, which we have set to 58. And then as you can see in the first generation already, it's already manipulated a stuff. It's checked to say if something is alive or something's dead, and then it knows where to draw if it should remain alive or dead. And it does that for 10 generations. There's not too much of a change every single time, but it's as simple as that. I'm going to have all this code posted for everyone to check it out as well. I have a different version. It's basically the exact same thing, but it generates images as well. And we'll just run that. And as we can see, this is generation 10, 9, but we can look at the images as well for that. And let's create, I guess I'm going to show you just one image. It's going to be you can look at Gen 7. It's going to be like this. And we should be able to create a GIF or a GIF or whatever you want to call it with this. So I'm going to just look for that. And here is what I used to create the GIF. Now I'm going to overwrite the original. And So let's look. This is kind of what it looks like. Sorry, I keep flipping around. I don't know why I keep doing that. Okay, but yeah, this is the GIF of it happening of every generation. Looks like this, and I guess I'll pull up the final one so you guys can compare it. That's what I was thinking about doing. That's why I flicked it around a few times. But here's this one, and here is this. As you can see, the scaling is a little bit different because I was saying the height for the characters were a little bit taller. But as you can see, there's this little blurb down here, and it's down here, and it has this 2 holes up here. And that's these ones right here. Unless I have it rotated, maybe. No, I think it's the same thing. But yeah, that's basically it. I guess I can quickly show you how I did the filing as well. This is the other file. So right here, I just have this function called save image, and it's just saving it as a PGM file. It's like extremely basic file, but I just use I guess IO streams all I think I needed. I didn't need anything special to load in the file, but I'll have this in the GitHub. Basically, it just creates this file with this given name with PGM at the end, and then it states some header stuff, which is telling you like the width and the height of the image it's going to be, and then I loop through everything. And then basically, I just have it set it to a black or white block if it's supposed to be that. And then you close it, you print a new line. It's an extremely simple file format. But yeah, if you guys are interested in that, just to let you know, if you guys were to run it, the code provided, it's going to do this. So it's going to create the 10 files or for every generation, every single time. So you guys might want to go ahead and comment this out whenever you guys do it. The same one, this one is the original one as well. But yeah, I guess if you guys wanted to use this like in a game or something, you would just be able to take that new 2D array that you have and you just use it in your game. If in case you wanted to save it to a file, you can just output that directly to a file and then read it in. I've covered over stuff like that in different videos. But thanks again for watching. I hope you guys enjoyed it. Hopefully my video was clear. I kind of jumped around and talked about a few different things and stumbled it around a little bit, but hopefully that was okay. If you guys enjoyed the video, please leave it a like. If you guys didn't like it that much, give it a dislike twice. And if you guys are new to the channel, feel free to subscribe. See you guys again next time. Bye.